Okay, what I'm about to show you is probably one of the craziest and most ridiculous integration techniques that I know of. So what you're going to be able to do is you're going to be able to integrate between 0 and pi over 4 ln of basically any trig function. Yeah, let's get started. So first we are going to define two integrals. The integral between 0 and pi over 4 ln sin x, which we're going to refer to as I. And then we're going to have another one we're going to refer to as j, which is going to be the same but it's cosine x. So ln cos x. Now, on their own, these integrals are quite awkward to work out. However, if we have I plus j, where we add these integrals together, it's actually much easier to integrate. And if you do I minus j, it's also much easier to integrate. So we can use I plus j and I minus j to be able to isolate I or j. So we're going to say I plus j is the integral between 0 and pi over 4. And then we're going to add these two together. And when we add logs, then we can multiply what's inside of them. So this then becomes ln sin x cosine x. And then I minus j is integral between 0 and pi over 4 ln, and then we can divide sin x and cosine x. So you have sin x over cosine x, which is just tan x. And I would advise that you just remember and like memorize what I plus j and I minus j is if you're going into integration B or something like that. So this is minus pi over 2 ln 2, and this is minus g, where g is Catalan's constant. So I'll get into how you get to these in a minute, but just for how you want to use I plus j and I minus j to work out any of these, let's say you want to work out ln of sec squared x. This is the same as, because we can bring this power out of the log, so we can say that this is 2 out of the integral between 0 and pi over 4 of ln 1 over cosine x. And then we can bring that power out as well. So this is ln cosine x, and that is negative. And we see that j is ln cosine x, so this is just minus 2j. And if you want to get minus 2j using I plus j and I minus j, we can just do I minus j minus I plus j. And this gives us minus 2j. So that's how we're going to want to use it. So as for how we work out I plus j and I minus j to begin with, let's get started on that. So start with I plus j. I plus j is the integral between 0 and pi over 4 ln sin x cos x dx. So what you'll probably notice is that this can be represented as the sine double angle rule. So this then becomes integral between 0 and pi over 4 ln half sine 2x. And we can then just take this bit out here, the ln a half, and integrate that. So we are left with ln sine 2x minus the integral of ln 2. So we can just say that's minus pi over 4 ln 2. So let's put dx here, dx. So that's I plus j. Now to integrate this, first we're going to do a u sub for 2x. So we can say u equals 2x du equals 2dx. So now I have I plus j equals half integral between 0 and pi over, and then this is 2x, so that's pi over 2 now. And then this becomes sine of u du minus pi over 4 ln of 2. So this should be, I mean, this is a very, I'd say famous integral, but this is a very common integral. So if you don't have this memorized by now, I advise you do. But if you don't, here's how we do it. So first, let's say a equals the integral to 0 and pi over 2 of ln sine x. So that's just this integral here, okay? Now, what we're going to do is we're going to use King's rule. And what King's rule is essentially you make a u sub for the sum of the limits minus x. So you have u equals pi over 2 minus x. And what you'll see this will do is, for the limits, we have pi over 2 minus 0 on the bottom, which is pi over 2. Oh yeah, I should probably write d equals minus dx. So you have pi over 2 minus 0 on the bottom, and pi over 2 minus pi over 2 on the top. And then, because of this, we have a negative out front. And you'll probably notice that we can actually use this negative to flip the bounds of the integral. So this now becomes between 0 and pi over 2. So what King's rule lets us do is it lets us keep the bounds of the integral the same when you do the substitution. However, now this is sine of pi over 2 minus x. And sine of pi over 2 minus x is cosine. So that's cosine x dx. So these integrals are the exact same. So if we add them together, we get 2a equals the integral between 0 and pi over 2 ln half sine 2x with the double angle rule as well. And like before, you can take out that constant 0 to pi over 2 ln sine 2x dx minus pi over 2 ln 2. So now for this integral here, we can just do the same thing as we did before. So you say u equals 2x, du equals 2 dx. So now I have 2a equals the integral to 0. So that's pi over 2 times 2. So that's just pi. And then ln sine u du minus pi over 2 ln 2. Now, for this integral here, if we think about the values that sine x takes between 0 and pi, so we have this little graph here. So that's pi. That is pi over 2. So you see that between 0 and pi over 2, sine x takes the same values as between pi over 2 and pi. So we can say that this integral here, the integral between these values, the integral between these values here is the same as the integral between these values here. So this integral between 0 and pi is the same as 2 lots of this integral between 0 and pi over 2. And I realize this should be a half because of the substitution. So what we end up having is 2a equals half, and then since we're integrating between 0 and pi, that's the same as twice integrating 0 and pi over 2. So I have twice integrating between 0 and pi over 2. ln, let's say sine x minus pi over 2 ln 2. And you see that these cancel out. And what you see is that ln sine x between 0 and pi over 2, that's actually just a. So we can go ahead and say 2a equals a minus pi over 2 ln 2. And as such, a equals minus pi over 2 ln 2. So that's how we work out that. So as I said, this is something that's fairly common, so you'd probably already know how to do this, or just memorize it if you don't, or learn King's rule. So that's that. So I plus j equals a half of that minus pi over 4 ln 2. So I plus j equals a half of that, which is minus pi over 2 ln 2, minus pi over 4 ln 2. And this gives us minus pi over 2 ln 2. So there we go, that's how we work out I plus j. Now for I minus j. So I minus j is the integral between 0 and pi over 4 log tan x. this is, I mean, I've said it like a billion times. You just want to recognize this, okay? So as this being minus g, or at the very least, spot that you can do a u substitution for tan x. So you say u equals tan x, du equals sec squared x dx. Now we can say I minus j is integral between 0 and 1 of ln u over 1 plus u squared du. And this here is basically a standard result of negative g, where g is Catalan's constant. Now, how you get there is kind of interesting. So we see that we're integrating between 0 and 1. So this lets us actually express this 1 plus u squared as a geometric series. So if we say 1 plus x squared is the sum to infinity, and the common ratio is minus x squared. And then we can take out the minus 1, x to the 2n. So we can do that because we're integrating between 0 and 1, right? So now we can say I minus j is the integral between 0 and 1 of ln x multiplied by that sum. N equals 0, infinity, minus 1, then x to 2n dx. Now, this here is actually just a constant, so we can just take it out. You have I minus j equals n equals 0 and infinity minus 1 to the n, and then we have the integral between 0 and 1 of ln x times x to the 2n. And for this integral, we can just use integration by parts. So we're going to say integration by parts. So we say u equals ln x, u dash equals 1 over x, v dash equals x to the 2n, v equals x to the 2n plus 1 over 2n plus 1. So we have I minus j equals the sum to infinity of minus 1 over n, and then what do we have here? So we have ln x dot x to the 2n plus 1 over 2n plus 1, and that's between 0 and 1, minus 1 over 2n plus 1, integral between 0 and 1 of, that'd be x to the 2n plus 1 over x, so that's just x to the 2n. So that's that. Now we're going to say I minus j equals, and then we want to evaluate this first. So this actually integrates to 0, sorry, evaluates to 0. So we can just say n equals 0 to infinity of minus 1 to the n, and then that's just 0. So we have minus 1 over 2n plus 1, oops, 2n plus 1, x to the 2n. And we can just integrate this nice and easily. So n equals 0 to infinity of minus 1 to the n. And this becomes minus 1 over 2n plus 1 squared. So if we rewrite this as minus the sum to infinity minus 1 to the n over 2n plus 1 squared. And this here is the definition of Catalan's constant. So we can say this is equal to negative g. So there you have it. That's how you work out I plus j and I minus j. So putting this all together, we wanted to work out, it was like ln sec squared x. So we confirm that this is the same as this integral here, which is minus 2j. So what we can do is, to get minus 2j, we just do I minus j minus I plus j. And this gives us minus 2j. So I minus j is minus g, I plus j is minus pi over 2 ln 2, and this gives us pi over 2 ln 2 minus g as our final answer. So there you go. That's how you integrate between 0 and pi over 4 the log of any trig function using the I plus j meta.